Hello, and welcome to Conversations with Matt DeLockery. In the last episode, we began another search for a God by looking at the beginning of the universe. Because, if there is a God, the origin of the universe is one of those places we might expect to find evidence of that God's existence, whichever God that might be. Now, this particular search for a God has to do with the origin of the universe, or, more specifically, the question, did the universe begin to exist? In the last episode, we said that whatever begins to exist has a cause. We essentially said that if there is an effect, there must have been a cause. Now, what we're trying to do is ask the question, did the universe actually begin to exist? Because if it did, when we put those two premises together, we end up with the universe having a cause. Whatever begins to exist has a cause, plus the universe began to exist, equals the universe had a cause. So, did the universe begin to exist? This is going to take several episodes to cover, because there are a number of ways to address this question. Specifically, we're going to look at 4 different ways to try to find an answer, 2 philosophical and 2 scientific. Today, we're going to look at both of the philosophical ways. Now, I say philosophical, but really it's kind of philosophy and kind of math. Relax, I don't actually expect you to do any math or even be good at math. Coming up with the sorts of things that I'm going to talk about requires a lot of math, but understanding them really doesn't. Today we're going to talk all about the concept of infinity. And in order to understand how this applies to the age of the universe, we need to understand the difference between 2 kinds of infinity. And yes, there are different kinds. The first kind I want to talk about is the potential infinity. This is the infinity that most of us are familiar with. It's represented by the mathematical symbol that looks like a figure 8 that has fallen over on its side. So, to imagine something that is potentially infinite, think about standing on one side of your living room and attempting to walk to the other. But when you do, you walk half the distance to the other side of the room. Then you walk half of the remaining distance. Then you walk half of the remaining distance again. You could keep on doing this forever, couldn't you, without actually ever reaching the other side? That is, you could do it forever without reaching the other side, as long as you only covered half the remaining distance. At some point, we would actually cover more than half the distance and just get to the other side, but you see how this works, right? You could keep on dividing the distance in half forever, and you would still never get to the other side. That's why this is called a potential infinity. It's moving toward a limit, but it never actually gets there. It's moving towards infinity, but it never actually becomes the infinite thing itself. Let me give you another example that might show this always growing but never getting there aspect a little better. Imagine you're out in space, or in that white construct room in the Matrix. No features, it's just an endless blank. Now, imagine further that you're standing on a square stone, say 2 feet by 2 feet, and there's another one in front of you, also 2 feet by 2 feet. Since there's nothing else as far as you can see, and apparently nothing else to do, you step on the second square stone in front of you. Now, as soon as you do this, a third one pops up in front of you, right in line with the others. So, you step on that one, and as soon as you do, a fourth one shows up, just like the third. You step on that one, and a fifth one shows up. Now suppose this process keeps up for as long as you keep stepping on the new stone. What you have here is a potential infinity. At any point in time, you could count all the stones and it would be a finite number. There are not an infinite number of stones. However, because a set is always growing towards an infinite number, it is called potentially infinite. Do you understand? That's a potential infinity. The other type of infinity we need to talk about is called an actual infinity. The mathematical symbol for this is the Hebrew letter Aleph. Just Google the word Aleph, A-L-E-P-H, and the symbol will pop up. Unless you've taken some pretty high-level math, you have probably not encountered this in school. However, the concept is actually much simpler than the potential infinity, even though doing math with it is not. The actual infinity is exactly what it sounds like. It is actually an infinite number of things. Whereas the potential infinity was always growing towards an infinite number of things, but never reaching it, The actual infinity actually is infinite. So think about what it would be like to have an actually infinite number of pennies, for example. You're not forever adding one. You're just there. You're actually at infinity. You have an infinite number of pennies. Already you can probably see the problem with this. If you have an actually infinite number of pennies, where would you put them? You couldn't put them here on Earth, because even if you stack the pennies over the entire surface of the Earth as high as the moon, ignoring for the moment where you got the material to make all these pennies, that would still be a finite number of pennies. Now, it would be a lot of pennies, but with enough time, you could count them. The thing is, even if you filled the entire universe, you still wouldn't have an infinite number of pennies. It would be an absolutely ridiculous number of them, but it would still be a finite number. Assuming the universe is finite, it is not possible to have an actually infinite number of pennies in the universe because the universe just isn't big enough. You would need an infinitely large universe filled with pennies. Okay, so now we have done two things. We have looked at the difference between actual and potential infinities, and we have seen that an actually infinite number of material objects cannot exist in this universe. What we need to talk about now, and how we bring this back to our original question, is whether an absolutely infinite number of things could exist at all, regardless of the question of where you might put such things. Because if the universe is infinitely old, the number of seconds, days, or years prior to now would be actually infinite, right? It could not be potentially infinite because, if you remember, the set of potentially infinite things is actually finite, but it's always growing towards its limit. But remember, we're already here, so the series of past events is over. If it is infinite, then it must be an actual infinite, because a potential infinite would have hit its limit already, the present, and therefore be nothing but a finite number of events, which would of course mean the universe began to exist. If you didn't follow that last part, don't worry. Just know that if the universe is to be infinitely old, there has to be an actually infinite number of past events or moments in time prior to now. The question is it logically consistent for an absolutely infinite number of anything to exist in reality? Probably the best example to show the sort of absurdities that would result from an absolutely infinite number of things existing in reality is something known as Hilbert's Hotel. Now, I told you that the modern form of this argument that we're talking about has been largely developed by a man named William Lane Craig. A few years ago, he came and spoke to the group I lead at Georgia Tech. I'm going to play a clip for you from the talk he gave in which he briefly explains Hilbert's Hotel in response to a question from the audience, because he can explain it better than I can. Here we go.
When you mentioned an actually infinite number of things cannot exist, you mentioned Hilbert's Hotel.
Yes.
Could you explain that example and what that is and how that relates to God?
Yes, I'll try to do this
infinity?
very briefly. David Hilbert was perhaps the greatest mathematician of the 20th century. And to illustrate the strange nature of the actual infinite, he invites us to imagine a hotel that has an infinite number of rooms in it. Moreover, he says, imagine that every room is occupied. Now, you have to have that firmly in mind. There is a flesh and blood person in every single room throughout the infinite hotel. Now, Hilbert says, suppose somebody shows up at the guest registry wanting to check in. The proprietor says, of course, no problem. And he moves the person who was in room 1 into room 2. The person who was in room 2, he puts in room 3. The person who was in room 3, he puts in room 4, on out to infinity. As a result, room 1 now becomes vacant, and the new person is easily accommodated. And yet, before he came, all the rooms were already full. Then Hilbert says, imagine that an infinite number of new guests show up at the front desk, and again, every room is already occupied. No problem, says the manager. And he moves the guest in room 1 into room 2. He moves the guest who was in room 2 into room 4. He takes the guest who was in room 3 and puts him in room 6, putting every guest in the room number double his own. Well, since any number multiplied by 2 is always an even number, right? All of the odd-numbered rooms become vacant, and therefore the infinity of new guests is easily accommodated. And yet before they arrived, every room was already full. I think these sorts of absurdities show the impossibility of the existence of an actually infinite number of things, because there's nothing about the illustration that hangs on it being a hotel. When you have an actual infinite, you generate these kinds of crazy situations that I think are plausibly, metaphysically impossible.
Okay, so did you understand the point of what he was saying? According to the mathematician David Hilbert, if an actually infinite number of things were to exist in the real world, you would run into all sorts of impossible situations. On Hilbert's view, the actual infinity is a useful mathematical tool, but such a thing could never exist in the real world because of the logical contradictions that would result. But remember that we said that if the universe were infinitely old, the number of moments in time between then and now would represent an actually infinite number of things. However, since an actually infinite number of things cannot exist in the real world, that means that there cannot have been an actually infinite number of moments in time prior to now. So, the number of moments in time prior to now must have been finite, which means that the universe is finite in age, and the universe began to exist. Again, because an actually infinite number of things cannot exist in the real world, and the number of moments prior to now would represent an absolutely infinite number of things, the number of moments prior to now must be finite. And that, of course, means that the universe began to exist. So that's the first of the reasons that we're going to talk about today to think that the universe began to exist. The impossibility of an actually infinite number of things existing in reality. But let's suppose for a minute that an actually infinite number of things could exist in reality. In that case, there's something else we need to discuss, which brings us to the second question for today. Is it possible to traverse an actually infinite series of things? In other words, if you took an actually infinite number of things and laid them all in a row, could you get from one side to the other? Well, let's start with the most obvious example. Could you count to infinity? 1, 2, 3, 4, 5, 6, 7, and so on. Well, right away, you have a problem. This represents a potential infinity, not an actual infinity. No matter how long you counted, you would have counted only a finite number of numbers. Remember, a potential infinity moves towards a limit, but it never actually reaches it. It goes towards infinity, but it never gets there. So this wouldn't work. Okay, well, what if we count down from infinity? Let's suppose that the infinity is already there and we just started counting down. This would have the added benefit of representing time better because we're trying to get from infinity past until now. The problem is, though, how could you ever start counting? What number would you start on? I mean, you're basically singing the biggest ever 99 bottles of beer on the wall song ever. 99 bottles of beer on the wall, 99 bottles of beer. You take one down, you pass it around, 98 bottles of beer on the wall. As amusing as that song is to start, nobody ever likes finishing it. But really what you'd have to do is sing an infinitely long version of that song. But even assuming you could do that, and even assuming that you'd want to do that if you could, what number would you start on? Before you could start with 99, you would have to have already sung 100. But before you could have sung 100, you would have to have already sung 101. It just isn't going to work. And even if you decided to start with infinity bottles of beer on the wall, it's not going to work. Because what's going to happen is you'll have to count infinity, infinity minus 1, infinity minus 2, infinity minus 3, infinity minus 4, etc. But isn't that basically the same thing as trying to count up to infinity? 1, 2, 3, 4, etc. The only difference is that you're saying infinity minus in front of every number. But really, it's the same thing. You're always going to be saying infinity minus something. It's not like at some point down the road you're going to switch over and say negative 100,028 or something like that. So it's really just the same thing as trying to count up to infinity. And, as we already saw, That's not going to work. Besides all that, though, there's still a further problem. Suppose you met someone who claimed to have been counting down from negative infinity from eternity past. -3, -2, -1, 0. Whew, done. Could you believe him? Besides the obvious issue of mortality. Here's the question. Why didn't he finish yesterday? Or the day before? After all, an infinite amount of time had already passed, right? I mean, if he'd been counting down from eternity past, he literally had an infinite amount of time to finish the task. So, why hadn't he already finished? Really, he should have already been done. We could never believe someone, even if that person were immortal, who claimed to have counted down from negative infinity because at any point in the past he should have already been done. There would have already been an infinite amount of time for him to finish. So it doesn't look like it's possible to get from one side of an absolute infinity to the other. So let's consider what that means. The number of past events, or number of seconds, minutes, hours, days, etc., prior to now would be absolutely infinite if the universe were infinitely old. And if it's impossible to get from one side of that to the other, then we could never have gotten to where we are now. That means then that the universe cannot be infinitely old, which of course means that the universe began to exist. So today we've looked at two different reasons to think that the universe must have begun to exist based on the concept of the absolutely infinite. I know that can be really tough to get this sort of stuff if you're not used to it. If you've had trouble, take another listen to this episode or look up some of the stuff elsewhere. I put a link to a longer explanation of Hilbert's Hotel in the description of this episode, as well as an explanation about why you can't traverse an actually infinite series, in case those will help you. But we have not gotten to the end of our investigation into whether or not the universe began to exist or not. Perhaps you weren't convinced by what I said in this episode, or perhaps I didn't explain it very well, or maybe it's just wrong. Anyway, we have two more reasons to think that the universe began to exist, and they're both scientific. So the next thing we're going to discuss is the scientific reasons to think that the universe began to exist. So make sure you subscribe to this podcast so you can keep up with the rest of this discussion. Next week, we start the science.